Hey everyone, I just wanted to take this opportunity to talk my way through homework 1. I was just going to post a key to it, but I think it might be more helpful if I kind of talk my way through it so that you can hear what I'm thinking while I'm doing it. I don't know if that actually is going to turn out well or not. We'll see. We'll see. Anyway, I'm going to share my screen. Let's share up. All right, so you can see I've got nothing going on here. So I'm going to go to the book, and we're going 1 through 5 in chapter 1. So if you get the PDF of the book, this is what it looks like. I actually kind of like the PDF over the online version. It's got all these links that are, I guess they're sort of present in the online one too. All right, so we're going to start with number 1 here. All right, so we have 2 researchers here, and they're doing something. I forget what. Let's go look. Use following information to answer the next 5 exercises. This is a little bigger than I thought. Come on, computer. Studies are often done by pharmaceutical companies to determine the effectiveness of a treatment program, obviously. Suppose the new AIDS antibody drug is currently under study. It's given to patients once the AIDS symptoms have revealed themselves of interest. Okay, so here's where we want to pay attention, is the average length of time in months patients live once they start the treatment. Oh, it's a shame I have to measure in months. 2 researchers follow a different set of 40 patients with AIDS from the start of treatment until their death. Follow presumably 2 different sets of 40 patients from the start of treatment until their deaths. Oh, such a sad problem. I should write a different one. The following data is collected. Data are collected. Here they are. Researcher A, some months. Researcher B, some other months. Determine what key terms referred to in the example for researcher A. Population. So the population for both researchers is the same. It's all people with AIDS who receive this treatment. All patients with AIDS who treatment. Sample. Well, the sample is the 40 people that that researcher A is following. And I'll just say the 40 people is following. You can't. I keep not. Sorry, I keep not sharing not sharing my screen. I'm going to go ahead and just share my page so that you can. Well, we'll see what you can see what the questions are if you look them up yourselves. So there we go. This is what I'm looking at right now. Parameter. So the parameter that they were interested in. So when they say parameter, what they mean is the parameter that they are studying, and they said that they are studying the average length of time that someone lives after they start the treatment in months. So the parameter here is the length of time that people live after receiving treatment. The length of time the patient survives once they start. The statistic, same thing. The statistic also the patient survives once they start treatment, but it refers only to the patient's study. Then what variable? Time and the variable is time, I guess. Time. All right, 50. Oh, this numbering, I have it set on automatic numbering. I wonder if it will let me change the numbering here. All right, so what if I do this? Options. All right, I'm just going to leave it as 6 for right now. I'll figure out how to change it a little bit later. You don't need to see that in the video. So this 6 is actually 50. And we'll come back. I'll fix it in the fixed after we're done here. So yeah, let me switch back to here. So I answered these guys, so I'm going to go down to 50. Find it goes fastest when I fit one page. Yep. It's too much. What is the population interested? All right, so 50 through 52. Use the following information to answer the next 3 exercises. A Lake Tahoe Community College instructor is interested in the mean number of days Lake Tahoe Community College math students are absent from class during a quarter. What population is she interested in? Students are absent from class during a quarter. Lake Tahoe Community College math students. D. Right, it specifically says that. All right, so 50 is D. D. Consider the following. X equals number of days Lake Tahoe Community College math student is absent. In this case, X is an example of a variable. Yeah, it's a variable. Sorry, that was A. So this is 52. Structure sample produces a mean number of days absent of 3.5. This value is an example of a, well, this is a statistic. So for first, a couple things. This isn't a parameter because it's about the sample. It's not data because it's not just a list of absent days, and it's not a variable because the variable is like the name of the thing that you're studying, like a number of days absent, right? Like it says up here. So this is a statistic. It's a number about the sample. Put that down here. Statistic. All right. Can I start renumbering? Wait, why didn't it let me do that before? Number list. All right. So what number is this then? 53. Yeah. So this is 53 that we're doing. All right. All right, for the following exercises, identify the type of data that would be used to describe a response: quantitative discrete, quantitative continuous, or qualitative. Oh, I think I didn't describe, I don't know if I put on the assignment that you didn't have to worry about discrete versus continuous. Did I? I hope so. Oh, I didn't. What a turkey I am. Sorry about that. I'm not worried about discrete versus continuous. But I'll explain it right here just so you can see what they are. So discrete is things that can only be certain values. So like very commonly integers, right? 1, 2, 3, 4. If I ask you, for instance, how many people are in the room right now, right? It would be some whole number, right? 4 or 7 or just 1. But you couldn't have like 2.5. Whereas continuous is anything in a range. So for instance, if you have a water bottle, right, and it holds, let's say, 20 ounces of water, then you could have anywhere between 0 and 20, including all the fractions in between, fractions and decimals in between. So it's anything between 0 and 20, including literally everything between there, not just the integers. Whereas discrete can only be certain values. Now, discrete doesn't have to be integers. It just usually is. Discrete literally, so like if you measured to the nearest ½ inch, for instance, heights would be discrete, even though heights are normally continuous, right? If you say, how tall is this person? Like, so I'm 6'1", and so you would say, I'm 6 feet 1 inches tall. Now that's not actually true, right? That's what I tell everybody because that's about right. I'm actually like some fraction of an inch shorter than 6'1", so I'm somewhere between 6 feet and 6'1". But I just round to the nearest inch. So I'm sort of making it discrete data out of continuous data. So you can make data discrete by only measuring it to a certain standard. But the idea of a variable height or length, either one is continuous, but you can sort of report it as discrete. So you can turn discrete, or you can turn continuous data into discrete by only measuring to a certain number, right? And then only reporting every inch or half inch or whatever, or every, how long is it till the nearest hour? Is it 15 minutes, 20 minutes, right? Even though it's like, it might be 19 minutes, you might say, oh, it's 20 minutes until 5 or whatever. But anyway, I'm off on a bit of a tangent there. But so discrete is only certain values, and continuous is anything in a range. One thing that you want to be careful of here, if you're thinking of continuous versus discrete, continuous does not mean infinite, and discrete does not mean finite. People get those mixed up a lot. Like with the water bottle example I just gave you, there's not like you can't go 0 up to infinity. That's not how continuous works. It only goes up to whatever the maximum value is. Now there are an infinite number of things in there, but discrete can also be infinite, right? How many atoms are there in the universe? Not technically infinite, but you're counting up, right? You're counting up potentially indefinitely. So you really want to think of it as continuous, anything in a range, which can be infinite but doesn't have to be, and continuous, or excuse, and discrete, only certain values, usually integers. Not always, but usually. All right, so number of tickets sold to a concert. Well, the word number is a dead giveaway here. And we can only sell 1 or 2 or 3, so this is discrete. That's discrete, quantitative discrete. So so I'll just say what they are, and then I'll go type them up on homework later to post. So it's quantitative discrete, percent of body fat. So that could be anything in a range between 0 and 100. I mean, obviously not actually 100, but it's anything in a range. So this is a number, and it could be anything between 0 and whatever. So this is quantitative continuous. Favorite baseball team is not a number, that's qualitative. Time in line to buy groceries. Well, time in general is continuous. It's quantitative continuous. Even if you could only measure it to nearest minute or second or whatever, but the time itself is continuous. Number of students enrolled in Evergreen Valley College, that is quantitative discrete, right? You can only have a whole number. Most watched television show. Whoa, what the heck just happened there? Most watched television show is qualitative. Brand of toothpaste is qualitative. Distance to the closest movie theater, that is quantitative continuous. And age of executives in Fortune 500 companies. Now, time is continuous. You usually report this to the nearest year, so you could argue that this should be quantitative discrete, because if you ask someone how old they are, they'll say, I'm 23 or I'm 47 or whatever. So they're only measuring to the nearest year. But time itself and age are continuous, right? You're continually aging, and so there's like a smooth progression to the of time, not like suddenly you're exactly 47 and then the next second you're 48, right? That's not how time works. Number of competing computer spreadsheet software packages is quantitative discrete, because there's a whole number of those. Another way you can check this is how much versus how many. How much is going to be continuous, and how many is going to be discrete. How many, so like water bottle example, right? So how much water is in this water bottle? You say how much, not how many water. If you want to know how many people are in the room, you say how many people are in the room, not how much people are in the room. And so in general, like that's not a hard and fast rule, but it's a pretty good rule of thumb. How much is continuous and how many is discrete. All right. What was the 81 and what were the other ones? 81 and 88. Yeah. So I'll go type those up in a little bit. All right. So 81, 88. Let's scroll down to those guys. One of them's like, I think 88's the graph one. Which one's which? Yes, the table. Okay. So the way we want to solve this, 60-year-olds with gum disease were asked the number of times per week they used to floss before their diagnosis. The incomplete results are shown in table 1.34. Okay, so they told us 60 adults, so that means that the total of the frequency column has to be 60, right? We currently have 45 and 4 is 49, so this must be 11. Right, so there's 11 people who would floss 3 times a week. This is a weird table. Nobody said 2. 0, 1, 3, 6, and 7. No 4s and 5s. All right. Anyway, this 3 has to be 11 because we need this to add up to 60 because we said there were 60 adults. And then for relative frequency, we're just going to do 27 out of 60, 18 out of 60, 11 out of 60, et cetera, et cetera, et cetera. You could also have figured this out, by the way, by solving a little equation. If we know that there are 27 over the total equals 0.45, you can do like 27 over x equals 0.45 and then solve for x. That would work. And then cumulative relative frequency, we're just going to add up the relative frequencies. What percent of adults flossed 6 times per week? 3. Well, it literally says right here 5%. What percent flossed at most 3 times per week? So 3 or fewer. Remember that at most means that's the maximum value. So at most 3 times per week would be 27 plus 18 plus 11 out of 60. But it's actually easier to do this and say that, well, okay, there's 4 people who didn't floss 3 times a week, so there must be 56 who did, or flossed at most 3 times a week, and so you get 56 out of 60. Whatever that number comes out to be. Oh, I guess it comes out to be 0.667, doesn't it? Since you can just add these two up, right? The relative frequency here, so 6.67% of people were in these two categories. So that must mean that there were 93.33% who were not. Oh, and it says right there. How convenient. Anyway, there you go. Yeah, I'll go make that table and put it in the homework. And then 88 was the other one. I believe this one's about the graph, right? Oop, where is it? 90. Yeah, okay. So an advertisement for Acme Investments displays the 2 graphs in figure 1.14 to show the value of Acme's products in comparison with the other guy's product. Describe the potentially misleading visual effect of these comparison graphs. So the big problem here is that there are no scales on the axis. I mean, they put hash marks, but they didn't label the axes. We don't know if this is, total value invested, because and Acme's going up and other guys aren't, because that wouldn't be useful, right? What we want is we want the average value in the portfolio to go up, but we don't know that that's what this is because they didn't say. Right. We also don't know what the scale is. Like, it's entirely possible that the scale, that maybe this is value of the investment over time. Maybe this is the x-axis is time and the y value, or the y-axis is value of investment, but that the scale is only like in pennies or something. So this is only like a nickel better than that one, right? That could be a problem too. So they need to label their axes. That's really the problem. Yeah, there's other things that you could argue that they should do, right? Investments is pretty vague. They really need to be more specific about that, but lack of labels is the biggest problem. Describe the potentially misleading visual effects of these comparison graphs. How can this be corrected? It can be corrected by labeling their axes. I don't think they need to do anything else. Maybe getting a little more specific about what they're showing, rather than just investments in general, right? Like, that's not useful information. You got to know what investment that is. Yeah, so that's it for homework 1. I'm going to go type that up and post it in, I'll see if I can figure out how to get a drive link into, or maybe I'll save it as a PDF and then you can look at the homework that way. Anyway, I think that's it for this video. I'll go ahead and make the other homework 2, 3, and 4 now at the same time, and then we can post them all up. All right, that's it for this video. I will see you in the next one.